Hello, this is Tim here. I hope you're keeping well. This is the video for lesson number 5, SolidWorks lesson number 5. Today, what are we going to work on today? What's going on here? Reading on tag documents. Let's get rid of that for a sec. We're going to work on 4 problems. We're going to work on this. There are all these Dr. Wall problems that you've seen me use before. They're a little bit more complicated and a little bit trickier. My plan is to go through this problem here. Excuse me for a sec. This problem here, this one here, and that one there. 4 of them, and they're all pretty hairy. Even for myself, I'd have to think about them, how to actually tackle them. So you're going to do 4 problems, and then you're going to have the usual homework. Now in the homework, I've given you 3 problems, and they're tricky enough. So this is really the last lesson that we're going to spend on problems, on parts I mean, and then we're going to move on to drawings next week. So we'll just start. We'll start with a spray head. I would tackle this. I was looking at this for a few minutes and I was thinking maybe I could do an extrusion here, a cylinder extrusion, and then another cylinder extrusion, and then maybe some chamfers on here. But really this is all, it's really symmetrical along the center line here, so this is something that we could revolve. It's just screaming out there to be revolved. So we could revolve this entire object with just one feature, and then we could put in these holes that are on the angled plane. So the first feature is going to be a revolve, and we're going to draw half of this spray head out. We'll revolve at 360 degrees. We're going to make one drill, we're going to drill one hole. That's going to be the second feature, and then we're going to array that hole around the cylinder like so. So we can actually do this with 3 features. We can get away with this problem. So let's one other thing. So in order to revolve this, we need to know the height from that line to the very, very top. Now it would have been nice if they included that, but I'll tell you how you get it. We have this distance here, and we have that distance there, but we need to know the distance from that line to that line, okay? And it's not shown, but we do know that this is a 45-degree line, okay? So let me just zoom in here for our 45-degree angle. That means the distance from there to there is the same as the distance from there to there. Okay, it's a 45-degree line. So if we can find out what the distance is from there to there, that's good enough. That'll give us this distance. So we do know that the outside diameter is 2.25. The inside circle, this one here, is 1.5. So the distance between them is 0.75. What does that mean? So what it means is this distance from that circle to there is 0.375. What's going on here? Let me just get rid of that. 0.375 from there to there. That means that that distance is 0.375, and then it means that that distance is 0.375. You add 0.375 to 0.575 and then to 2.050. Now I use a calculator for that. It equals 3. So the distance from that line to the top is 3 inches. There you go. Alright, so let's give it a blast. Now remember, with every problem that I give you, we're going to measure the mass properties. Okay? So I'll talk about that in a bit. So 3 inches. And what does it look like? It looks something like, come over, down, but let me see if I can remember what this thing looks like. So it comes something like this. Oh, it's 9 o'clock in the morning that I'm doing this. You'd think I'd be better. Okay. Okay, that looks about right. Okay. So this sketch is 3 inches. And then let's have a look. We have 2.050. So let's just do that one at a time. 2.050. And then we know that the distance from there to there is 0.375. And then we have this line, 0.575. It doesn't like that, it's over defined. I have the 3, I have everything I need. Okay, now what else do we need? I have this distance here, this circle. Oh, don't tell me they're missing that dimension. So this is 1. Okay, I think I can get this. This is 1 inch from there to there. Now how do we get from here to here? That's 1.5. Yeah, this dimension is missing. So we'll make this from that line to there, we'll make it 1.5 as well. Yeah, you can see that line there, there's that dotted line, so it's a little bit less. 1.5 we'll make it 1.4. Sorry about the confusion. So from that line to there, 1.4. Okay? So that means that this is 0.7. 1.4, 1.4, 0.7. Yeah, that's about right. And then this distance here, the 2.25. So from here to here is 2.25. What I'm going to do is, this is probably confusing you guys, I'm going to get myself a center line, and let's put that in, and then let's have some center line dimensions that make more sense. So from here to there, don't be like that. Let's try that again. 1.4, and what was this one, do you remember? 2.25, and there it is. Okay, and we know that that's 45 degrees, so let's just put a dimension in. From there to there is 45. So the only dimension that's missing is this 1.4. It's just unfortunately this chap here, whoever he is, he just missed it, and we'll use the common sense and we'll make one up. You should be able to figure out this 0.375, which I'm after telling you, so it doesn't really matter. Now, that's it. That's the first sketch. Nothing too bad there, nothing too tricky. Let's exit that. We'll go to features, revolve boss base, and it picks up the center line and it's going to revolve it. Now before we do that, yeah, we may as well, before we do that, let's edit the sketch and put, it looks like there's a nice little cutaway here. So it comes up 1 inch, 1.925, and then there's that curve. So let's have a look. So watch this. I'm going to show you this trick a nice little trick that I've learned. So I'm drawing a line coincident to that line. It really doesn't matter where. I'm going to add a dimension in now in a second. I come up straight away. This dimension I'm going to add in a bit. I walk away from the point, and then I come back and I hover over for a second, and look what it does. It turns it into a nice arc. The only issue with this is I need to make this tangent somehow with that straight line. Now, so do I need to put in, I think I need to put in, if I put in a straight line like that, or horizontal line, I can make this line tangent to that. There you go. Now we're in business. Okay. Yeah, I'm going to have to fix that again, I think. Okay, now what was it? It was 1.925. So let's get that. So from here to there, 1.925. Let's drag this, get this dimension out of the way and make it a bit neater. And then what was it? The distance from there to around the center line is a diameter of 1. Now this isn't going to work. Yeah, let's think about this for a second. This radius here is a ½ inch. Ah, lovely, that's better. A ½ inch. Okay, good. So what can I do? I'll leave all this here, and let's see if I can revolve this. I'll exit the sketch. I go to features, revolve, click a line, and I'll go right, selected contours. Turn off this thin feature. You've heard me say that enough. I'm highlighting this region is what I want, and it revolves at 360. Okay, so that's that. Let's take a section of it. Here we go. So the next step is drilling a hole on that face all the way through to there. Now this is going to be, let's see how this goes. Okay, so I need a plane that's normal to that face. Now let's have a look. That's not going to work. That's not going to work, and this is not going to work. None of them are going to work. Okay. Let me see if I can explain this. I need a plane anyway. So let's go to reference geometry. And I don't. This first, second, third reference. I remember how to put in. It's just from experience, really, how I do it. So let's play with this and see if I can get it to work. I'm going to click on this face, and it puts a plane on there straight away that's tangent. And we probably could use that. But if we give it a second reference, either that, let's say I'll give it that, what it will do is it puts that new plane perpendicular to the top plane, but also is that right, perpendicular? Yeah, but also normal to that plane. Okay, so you can do it a couple of different ways. Look, I'll show you again. Reference geometry, plane. I can pick the first reference. I can pick to be the top. The second reference could be this, and it gives me the same result. I'll show you another way. Reference geometry, plane. I don't even need to pick this top. I could pick. That's not going to work. That front plane is not going to work. But you'll see what I mean. And then the second reference will be this. That's not going to work. Plane cannot be perpendicular to axis of cylinder or cone. Current combination of references and constraints not valid. No luck there. Let's try it again. The front is not going to work for us. The top will work and the right will work. So I'll just pick the right. And then the second reference will be this. And then it puts it perpendicular to that plane and also lying up against the inline or the angular plane. So either way it works. So in order to get a working plane or a reference plane, we need to give that two references. You're going to have to play around with that, but I'm sure you're going to get that to work. Now, let's have a look. Let's create a sketch on this plane. Now, if you look at the dimensions, Dr. Walt has not given us the position of that hole. So I'm going to tell you, it looks like it's centered on that face. Now, what does that mean? He does tell us that it's a 0.2 diameter. That's good enough. So let's look normal 2 at this. And first thing I want to do is I'm going to draw a center line from the origin to something like that. I have a line now. Now I'm going to draw a circle. Now that circle, why is it not moving? Was it's mid-planed? That has to be too good to be true. But let's put our diameter of 0.2 on it. 0.2, and I can move this along the line. I'll get back on that line there. So I'll add a constraint. There we go. It can move along that line, but where along that line? What do I mean by centered? I mean the distance from that point there to that point there. I would like that circle to be centered between it. So how do I do that? Can I get a working point? There's a working point. Can I click on this edge here and go convert entities? There we go. Now I'm going to click on this curve that I've just made, and I'm going to make it for construction. And I'm going to do the same over here. Convert entities, click on the curve for construction. And that's what that looks like now. All of this work that I'm going to is to ensure that this hole is centered on that face. Now, let's do this. Let's measure this from that point there to that point there, and let's look at it. Okay? The distance is 0.53 of an inch. So, I'm just going to put a dimension. There's probably an easier way. Yeah, I'm making this hard. Watch this. Let's just put a line in from that point to that point. Let's make this for construction now. Hopefully you know what I'm trying to do. I make that point mid-plane. On the line. I have had to turn that line back on because it was highlighting this larger construction line. Make that midpoint. There it is, and it goes black. It's fully constrained. So, come on now. Let me see if I can highlight that line. Here we go. Okay. So just a lot of work to center that hole up. There's probably about 10 different ways you could do it. So just do your best and see if you can get that hole lined up. Now let's have a look. I'm going to exit the sketch. I'm going to go to extrude cut, and I'm going to cut that hole. And I'm going to, instead of this being blind, I'm going to go up to next. And what it does is it just cuts that until it sees air. Now I like that up to next. I don't think I've used that before. So there's a hole there. Let's turn off that plane. How do we turn it off? We hit the spectacles. Let's have a look at what this thing looks like. There it is. Okay, we got one spray head cut out. Now let's go back to the drawing. And how many of these do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8. A total of 8. Now, if we want to array this around a circle, we don't want a linear pattern because this is revolved. We're going to want a circular pattern. So there it is. The features to pattern, I can either click on this hole like so and it picks up straight away, or you can access the feature tree from here by hitting this plus button. So the features to pattern are not the revolve, we want to pattern the cut extrude. Now the angle or the axis of rotation is around that cylinder. That cylinder will work, and even this tapered angle will work, because they're all concentric. So I'll just pick this, and it says a total of 4, equal spacing. So we'll space those out 90 degrees, but we want 8, and that's it. 360 divided by 8 is 45, and there you go. So that circular pattern is a nice tool to have. And that's it. I'm taking the section plane there to see what does it look like. It looks great. Okay, so the usual stuff. I right click on material. The material that I want is plain carbon steel. Okay, then we're going to go to evaluate. I'm going to go to mass properties, and the mass of this part is 1.27 pounds. Okay, now if you made this with a lathe and you drilled those holes in and we put this part on a scale and it was made out of plain carbon steel, I guarantee you it'll be around 1.25 pounds. So that's the number you should be getting. If you're not getting this number here, or you should be getting it bang on, to be quite honest with you. But don't pull out too much hair if it's not, you know. So that's part number 1. What did we learn new there is just the circular pattern, and that's really it. Okay, I'll move on to part number 2 now in a sec. So I'm ready to, whoops, let me get my microphone here. I'm ready to move on to problem number 2. This is a good and interesting problem. I'll get into that now in a second, but let's have a look at it. It looks like a cauldron. It has, I would call this a flange at the top of it. It has ports, 2 ports on either side, and then it has a small port there, and then it has another port at the very, very bottom, or hole or connector port. So the first thing we want to do is get the shape of the cylinder, or get the shape of the cauldron. So we just have that curve there, and we know that the walls are 0.150 thick, so we'd probably use some sort of an offset, and we'll revolve at 360 degrees. Then we'll put on this flange at the top. Then we're probably going to draw one of these ports, and then we could mirror it over, and it's just, and so on. The one trick in this part is we need to create a plane that's away from the object and then extrude towards it, and you'll see what I mean now in a sec. So let's have a look. What dimensions do we need? The 3 inches is a good one, the 2.5, and then some of those curves. So let's give it a blast. What else do we need? Okay, let's give it a blast. Alright, so let's get rid of this one. You're going to save your parts, but you know, I don't really need it, to be honest. I'll create a sketch on the front plane, and I'm going to draw something like this. Right? I go away from the point and I come back to it, and now I have a curve, a little bit too much. Okay, something like that. Now let's put in a center line from the origin. Now I'm thinking, in this example, where do we want the origin? Probably at the bottom of the cauldron before we put in that bottom hole. So let's have a look. I need to remember 3 and I need to remember 2.5. Okay. Okay, good. So from there to there is 3 inches. And this diameter of the pot is 2.5. So let's see if I can just trim this bit of it away. There you go. And what was this? This was, I'm thinking it was 0.75. 0.75, 2.5 and 3. 0.75, 2.5 and 3. Okay. And then I also have to make this line is not, it's not fully defined. Let's make a tangent to that. There it is, fully defined. Okay. Now it's saying that the thickness of the walls are 0.150. So let's have a look. Offset entities, 0.150. Alright, that's the wrong direction. So hit reverse. Beautiful. Okay, I got that. Am I in the mood to do the flange now? Is there a dimension on it? Yes, there is. Okay. So let's put this flange in. So what does it do? I'm sorry to go back and forth. 3 inches to the very, very top. So this flange looks something like this. Comes out and down. And let's just trim this bit of it away. Now, let's remember this dimension, 3.25. So from here to here, 3.25. And what's the thickness of this? Now let's put this 3 inches back. So from here to here, 3 inches. Lovely. Now what's the thickness of this flange going to be? 1/4 of an inch. There it is, right there. Everything goes black. It's a fully defined sketch. Let's tidy it up a little bit. Why do we tidy sketches up? Because there's a good chance that someone else is going to look at your work. Now let's rotate this, and is this a fully enclosed region? It's not really there. There's an opening right here. So let's put a line in. That's it. So exit sketch, features, revolve, selected contours, the axis of revolution. See, there's an example there where it didn't figure it out, so we had to manually put all those in. And there's our cauldron with our flange. Now let's have a look. Let's get this first port on the right hand side. Okay, so let's look at the front plane. We call that the front plane. And let's look at the top and the right. Okay, I need to draw a port here on the right hand side, and I need to extrude it up to the surface. Now what? I need a plane. Now that plane needs to be 1.750. Remember that number, 1.750. I draw a circle there and I'll extrude it up to the surface. 1 3/4. So what plane will work? This right plane is good for us. Okay, you'll see what I mean. The right plane is good. So let's get a reference plane, and let's give it an offset of 1.75. Look at that. And we go, okay, is that a little bit far? Yeah, that's about right. 1.75. Okay, so let's create a sketch on that plane and go normal to. Let's look at it, and then let's create a circle. Don't worry about, I don't know if you can see that, but sometimes SolidWorks, I have a setting on my SolidWorks here to have not the highest resolution in curves, and sometimes it'll approximate stuff like that. Just when you see crap like that, don't even worry about it. Now, the distance, the diameter is 1 inch, so let's put that in. 1 inch, and let's get a center line, like so. Now we're gonna have to add in this is going to be a port, but I'm gonna have to actually cut it a different feature. So is there a height difference? Look at this, 1.25 is what we want. So the distance from that line there to there is 1.25. Now why is this not locking in? Because I haven't locked it into this center line. Coincident. Fully black, fully constrained. Features, let's extrude it up to surface. Now what surface do we want to extrude it to? This one right there. Now let's try something else. Can I make this up to next? That still works too. I like that. Up to vertex, no, that's not going to work. Up to next will work. No, maybe not. Let's try that again. Extrude this sketch up to next. No. Let's flip it. Up to next. Yeah, there you go. That works too. Either way it works. Up to next or up to surface. Okay. There it is. Now let's create a hole through this. Or that port is useless. So let's create a sketch on that face. Hit the space bar. Put a hole there. Or a circle. And let's look at the diameter. It looks like a diameter of, and here we go. We're missing another dimension. Yeah, this is 1 inch, but it's not telling us the hole going through it. We'll make that hole 1/4 of an inch. .75. Perfect. And then I'll extrude cut, and I'm going to go up to next, and it just cuts it right up until it reaches air. So very nice. Now watch this. I'm going to turn this plane off with the glasses. Let's have a look at this right plane. That's going to be a nice mirror plane. So let's click on mirror, and what do we want to mirror? You can highlight the features here, or you can do it over here. I think this is a better method, to be honest. You have more control over it. So you want to feature this one, and we want to mirror that one and this one here. Come on, there you go. I see both of them in the features to mirror, and I go, okay. Look at that. Lovely. What's next? So let's get the port at the front here. Now that port at the front is only 3/4, and let me have a look. It looks like it's lined up at 1.25. Okay, so let's do this. How far is it away though? It's 1.55. If I drew a straight line here, a center line, it's 1.55 away from that. So what do we do? Which plane do we want? That plane, the front plane. We're going to offset from that. Now, that penny kind of has to drop in your head. I don't know, you have to kind of look at it and pull out your hair a little bit about why I'm using certain planes to offset. I just do a lot of examples, and hopefully the students get it. That penny drops after a while. 1.55, and I'll create a sketch on that plane. Okay, I'm going to get a center line from that midpoint to that midpoint, and I'm going to do the same here from the origin to that midpoint up there. Everything is all centered, symmetrical, so it works out for us. And here we go. I lock into that point there, and we make this 0.75. I know I'm moving a bit fast here at the moment. I need some breakfast. Alright, let's flip this, and let's go up to next. And there's that first port. And again, I turn off the plane, I create a sketch on that face, and I go normal 2. I'm going to create a sketch on there, and we'll just make this a 1/2 inch. Or did they give us the dimension? No, that's great. A 1/2 inch will do. Use your common sense if you're missing dimensions. So we'll just extrude cut up to next, and there it is. Okay, the last port is at the very, very bottom. So what's nice about this is I don't need to do any funky plane work. I'll just create a sketch on that face. No, I'm lying. I do need to do that. Let's have a look. Yeah, he's we're missing another dimension here. Look at this. 0.75, but we don't know how deep this is. It looks like about 1/4 inch. It's the same thickness as that. Okay, so let's have a look. I'm going to create a sketch on there. Make this 0.75. Bring it a bit closer. Here we go. I'm going to extrude this 0.25, and then all I need is another sketch and another circle, and we'll make that a 1/2 inch, and I'll just extrude cut that up to surface, up to next. So let's have a look at a section view of this. That's it. You can see that Dr. Walt is after putting in a lot of fillets there, but we don't really know what they are. I'd rather leave them out, because I'll give you a number that will do the mass properties, but you could very easily, you know, if you were actually building this would be made out of tubular steel, and it would be welded together. So you would actually have welds here, and if we want to make welds in SolidWorks, a very easy way is just using a fillet around. Okay, so look, let's do this. We may as well practice it. Let's create a fillet, and let me see a good number. Let's make it 0.125. That's 1/8 inch, and let's do them all. Okay, lovely. 1/8 inch, and you'd probably see it's the same here. Okay, very nice. Okay, so let's have a look. If you've used 1/8 inch fillet on all of those, now why do I have 2 of them? There we go. Okay, 1/8 inch fillet on all of those edges that I'm showing you, you should get the same number that I have. So what do? We go to material, right click, plain carbon steel, evaluate, mass properties. What do I get? I get 1.34 pounds of weight. So it should be close enough to that. Alright, what's next? Hello, this is Tim again. I'm going to work on problem number 3, so let's give it a lash. So where do we start? The first thing that's kind of jumping out at me is we have a cylinder, a big cylinder with a flange on top of it. The cylinder is 1.5 diameter by 2.8, and then we have a flange on top of it, and then we have this angled piece of pipe that's coming in from an angle. Which shouldn't be too bad. So let's start. We're in inches, so I'm just getting a new part going, and we're in inches, and I'm going to create a sketch on the top plane. So let's have a look again. So we're a diameter 1.5, and then the wall thickness is 0.2. So let's put a diameter of 1.5 on this thing. I'll get another circle going, and I'll just put a wall thickness of 0.2, like so. So let's get out of the sketch, go to Features, Extrude Boss Base, and we'll make it, it's late now at the moment, 2.8. Alright, there we go. So I'll go OK, and I'll create another sketch on this, on that face right there. And I'll create another circle here. And what dimension do we need to put in? 2.75 is the outer diameter. And what we want to do is this edge here, I want to convert excuse me now, convert entities. Now the thickness of this thing, the thickness of the flange is 0.2. Excuse me now, 0.2. And I'll flip it. Okay. And looking down at this, we have 1, 2, 3, 4, 5, 6 holes that are spaced 60 degrees, and they're 1/4 of an inch. Now the center, there's a circle, a construction circle going on here. It's 2.25. So I'd start with that. So let's create a circle. Diameter is 2.25, and let's turn this, make this for construction. Alright, so what I'll do is I'm going to draw a circle on here, and I'm going to make it 1/4 of an inch, like so. And I'm going to go, instead of going linear sketch pattern, I want a circular sketch pattern. And the entities that I want to pattern are this circle, equal spacing, and we want to make it 6. And I'll go OK. Now, why is this not fully defined? For whatever reason, when we do a circular sketch pattern, I can grab that. Can I move it? There it is. What happens is all the circles are 1/4 inch, but for some reason they don't lock down this center point. So if I grab that center point and I move it in, it locks into place. Everything goes black, and now I can exit the sketch and go extruded cut. And I'll go up to next. I just want to cut those holes out until I see air. Alright? So, how many features do I have? I have 3 features. The cylinder first, the flange second, and the holes third. So let's go back to the drawing, and what else do I need? I need this angular piece of pipe. So, what am I going to do? There's a couple of different ways of doing this. Sorry about that. Too lazy to start again, to be honest. Alright, I'm going to create a sketch on this front plane, and I can also do it on the right plane. And you'll see what I'm going to do now in a sec. I'm going to draw a center line or a construction line up, whatever, and I'm going to come out. Now what is it? How far do I need to come up? I need to come up 1/2 an inch, and then I need a 60-degree line. So come up a half an inch, 0.5, and I need a 60-degree line here, like so. Okay, and then how far do I need to come out? I need to come out 1.5. So instead of it being a horizontal dimension, I'm using an angular, or is it aligned dimension is what I'm doing there. So let's have a look for a second. Let's make sure. It doesn't tell me. So this is called an aligned dimension. So I don't want a horizontal, I want an aligned. And I have my kind of construction sketch. So I'm going to exit out of that. And you like this. I'm going to go plane, reference geometry, reference plane. I click on the line, and then I'm going to click on the point. And what does it do? It's taking two references. The first reference was the line, the second reference was the point, and it puts it in like so. So this plane is touching the end point, and it's what is it? It's perpendicular to the line. Now I'm going to delete that and do it again for you. I can't do that sketch without, I can't do that plane without that sketch. So I put the sketch in first. This is kind of like a construction sketch, and then I go plane, I click the line, and then I click the point, and I go OK. Now I'll create a sketch on that plane, like so, and I have this origin. And I'm going to look at this normal to, and I'm going to draw a circle, like so. Now the diameter of this thing is 1 inch. Now why isn't it being locked into place? Because I need to lock it into the origin. Come on now, don't be an arse. Here we go. Still not locked in. So let's click the origin, click that, and we'll go coincident, and now it goes black. It's fully defined. Okay, 1 inch is what it was, and we'll extrude it up to the surface, or extrude to next. So I get out of here, I go extrude, I flip this, get it going in the right direction, and I go up to next, and that's it. It'll just keep going extruding until it reaches the surface. So I can do stuff like construction sketches like so. I'll turn it off, I'm done with it, and I'll turn the plane off. Now what's next? I'm going to create a sketch on here, go normal to, and I'm going to create a circle. I'm floating over the edge to say wake up center point, and then I have my circle. This wasn't put in the drawing. I'm going to make this 0.75, and then I'm going to cut that through, and I'm going to go up to next. So there we go. Let's look at a section view of this thing, and there it is. Now you can see on the drawing there's a couple of fillets here, small fillets that I'm pretty sure are not on there. Let's do this. Before I start putting the fillets in, let's apply a material, and we make a plain carbon steel is what we've been using. And I'm going to go evaluate, and I'm going to go mass properties. Now as of now, this mass is 0.9 pounds. So if we start adding some fillets, it's going to definitely change it. So let's add a couple of fillets just for practice. Now the first fillet, I'm going to try this 30 thousandths. Yeah, I'm going to apply a 30 thousandths fillet to each of those small holes. That's the first one, 30 thousandths, 0.03. The next thing I'll do is I'm going to have a fillet of 0.125, an eighth of an inch. Put one there. I see I'm after picking the whole face. Let's try that again. There's one, and there's two. Okay, so two little fillets. So the first one was a 30 thousandths fillets on each of those 6 holes, and then the second one was an eighth fillet on that edge and that edge. Now let's see what it changes. So we go back to mass properties, and what is it now? It's 0.91 pounds. So you should be pretty close to that. That's problem number 3 on the handout. And problem number 4, let's move on to this one here. Now let's just go back here for 1 second. And what did I want to say about this? Well, there's the section of it anyway. The only tricky thing was creating this sketch and creating that plane. Everything else you should have seen before, but kind of what I'm trying to show you today and tonight is how to create those kind of construction planes. Alright, I'm going to get out of here, and don't save it, I don't really care. Hopefully you're going to save your work. The next thing we want to do is this molded boot. Now, where do we begin with this? I'm looking at this first, and I have 2 features. I think I'm going to show you how to do a thing called, what is it called? What do I want to know? Teach you how to do. Let's get a new part open first, and I'll see if I can remember what I actually want to teach you. Something called a shell. So the first thing we'll do is, there's 2 things going on here. We're going to learn about drafting, and we're going to learn about shelling. So the first thing is we need the origin is going to be right bang in that center. Okay, so let's create a sketch on the top plane, and it's going to be a center rectangle, and this will make sense now in a sec. It's 4 inches by 3 inches, and we have the 3/4 inch radius. So let's see if I can remember that. 4 inches by 3 inches goes black. Let's get our radius going. 0.75. There's 1. There's 2. There's 3. There's 4. And let's go back and have a look. So that's the outer dimension, and what it has is it has a 5-degree draft with a 1-inch extrusion. Okay, let's give that a try. So let's get out of here, and let's look at it from a nice isometric angle, and we'll go extrude. Flip it, and we want a 1-inch extrude, but we want a draft of 5 degrees. Now that looks pretty good. Now we don't want it in this direction, we want to be going inwards. So there's one, just a solid draft. Don't worry about the wall thickness for the time being. We'll do that now in a sec. So the next thing we want to do is I'm going to create a sketch on this face right here. And I'm going to draw a circle. And the circle is, yeah, I get it now, 1.5 diameter. So that I can't do that. I need to get out of here for a sec. I need to actually, because I have this dimension 1.5, stop being a pain. There you go. I need to create a plane that's 1 inch away and then extrude up to the face. So let's get out of here for a sec, and let's go to plane, and let's go 1 inch away, an offset plane, an offset distance of 1 inch, and let's create a sketch on that plane. Now, because I've been wise with my right and front planes, and I've done this all in the center, I have my origin right bang in the middle of that part. So let's look at this normal 2, and let's create a circle. Now the diameter is 1.5, like so. And what am I going to do? I'm going to extrude this, flip it, and go up to next, and it will just keep on extruding until it sees that face. Now, am I done with this, or do I need to put in a draft? So let's click the draft, and let's give it a 5-degree draft, and instead of that we'll go outwards. Now, what does this mean? It means if I drew an imaginary straight line up there, that this is 5 degrees, and what it is, it's on all sides. and I'll go OK. So there's that 5-degree draft. Now to include the radiuses, this works. Okay, let's do this. So there's a radius of 0.2 right there, so we'll have to do that separately. So let's get a radius, what the hell am I saying? Fillet of 0.2, but they're both the same thing, radius of 0.2. So there's one. And then the next thing is a radius of 0.25. So I have the tangent propagation. Let's put this 0.25, and let's click any of these edges. It doesn't really matter. It'll zoom all the way around. Now there's that. Now, what's the last thing I need to do? I need something called a shell. Now, what does a shell do? It removes material from a solid body to create a thinned wall feature. It'll make more sense when I do it. So, I'm going to click shell, and we know that the shell wall thickness is 50 thousandths. So let's see what happens. So I'm going to put in 0.05, and I'm going to go OK. And it does its shell. Now, so what, says you. So I'm going to click on a section view and show you what's actually going on. So what it does is it just creates a wall thickness of 50 thousandths everywhere, and it hollows everything out. But that's not really what we want. We want an opening at the top and an opening at the bottom. So let me show you how to do that. So let's go back and edit this shell. Now first of all, let's turn off this section and edit the shell. And what's this? This is faces to remove. If I click one face and I go OK, it shells everything, but it's kind of a nice kind of drinking utensil there at the moment. But that's not really what we want. I also want to open up that face. So I right click, edit, and I click this one, and I can turn on show preview. And well, it doesn't really tell me much, but this is what we want. The shell is a very, very useful feature, but you kind of have to practice with it a little bit. But that's the first thing. You would use a shell for that molded boot. Okay. I don't know why it's going blue there, but it's kind of being a pain. Anyway, that's it. What are the new features that we kind of went over there? The tapered. You're going to see that in the SolidWorks certification exam, so you want to have a little bit of practice with it. And then the last thing was the actual shell. So that's part number 4. Can we have a look at your homework for next week as well? So SolidWorks Lesson 5 homework. So what is it? I have 3 problems for you. The first one is a castle or a chess piece. It's called a rook or a castle, and the first feature of this is going to be the revolve. So I'm pretty sure I'm very sure all the dimensions are here. So this is going to be the first feature. You're going to revolve this 360 degrees. The second thing is this top view, and you're going to create these cutouts like so. You're going to use the convert to entities, and the last thing is just a simple polygon that is a 50-degree taper angle. So you're going to draw this polygon in, and then you're going to have your 15 degrees extrusion. Okay, so you're going to practice that tapered extrusion a little bit. The next thing is a fairly complicated, it's not that complicated of a part, but there's quite a lot of features. Do your best with this. All the dimensions are there. You're just going to have to figure this out. You're going to have some holes there with some chamfers. This is called ordinate dimensioning. So the distance from there to that line is 0.21. The distance from there to that line there is 0.79. The distance from there to there is 0.79 minus 0.21. So you're going to have to do some arithmetic. You're just going to have to look at the different views and figure out the dimensions and things. If you're having major problems with this, email me and I will create another video. And then we have this problem number 3, which is just kind of a beast of a thing. I'm just throwing that out there to see what you can do. I'm pretty sure all the dimensions are there. You should be able to figure it out. You know, sometimes in industry, they're going to be complicated, and you kind of have to think up on your feet instead of me holding your hand. So good luck with that, and just email me if you're having major trouble, but I'd like you to spend at least an hour on each problem trying to figure them out before you do. Okay? Good luck, and I'll see you next week.